Let's define absolute value. So absolute value is the measure of the distance from the ideal or the center. So absolute value is the measure of distance. That word's important, distance. From the ideal or center and in industry, this distance is referred to as tolerance. So we looked at an example in the PowerPoint where we talked about manufacturing, and we had a bottle of salad dressing. And the ideal volume was 12 ounces. So we talked about that we could have a bottle of salad dressing, that it would be okay to sell a bottle of salad dressing that was 12.4 ounces, or a bottle of salad dressing that was 11.6 ounces. So that was considered acceptable. So the distance between 12 ounces and 12.4 ounces is a difference of 4 ounces either direction. And then that would make it okay. So remember, if we say that the absolute value, by definition, is the distance from center. So let's write it like this. The absolute value is the distance from center. So distance is always positive, isn't it? So when we think of distance, distance has to always be positive. I cannot walk -2 feet. So my distance is always positive. So when I go from 12 ounces to 11.6 ounces, I'm losing 4 ounces, correct? So that would mean that I'm losing 0.4 ounces, which is negative. But the distance from 12 ounces to 11.6 ounces is a positive 0.4 ounces. The same thing here. If I'm gaining 4 ounces here, the distance from 12 ounces to 12.4 is a distance of 4 ounces. So notice I have a negative value inside my absolute value signs. But what's the distance of -0.4? Well, the distance is a positive 0.4. If I have an increase of 0.4, then the distance between whatever my ideal is a distance of 0.4. That's why when you take the absolute value, you get positive values for both. So let's look at the example that I set before you. So here's my example. I kind of have it illustrated here a little bit, but we're going to write it out in words. Example. So I have an amount of tolerance to be within 0.4 ounces of the ideal volume, which is 12 ounces. And here's my ideal volume. Okay? So what does that mean? I'm going to do this in a number line form. So here is my center. My center is my ideal. That's 12 ounces. And remember, I can go positive 4, or 0.4. So this would be 0.1, 0.2, 0.3, 0.4 right here. And that would be 12.4 ounces. I can go another direction of 0.4 this way. 1, 2, 3, 4. Yes, I subtracted here, and I got 6 ounces. Okay, but this distance here is still a distance of 0.4. I may have gone in the negative direction because 12 minus 0.4 gives me 11.6. Here I went in the positive direction. 12 plus 0.4 gives me 12.4. But the distance itself between here and here is a positive value. It's all positive values through there. Okay? So remember, distance is always positive. Distance is always positive. Okay, so let's think about this because I want to be within. So let's think about what does that mean. I want to be within the distance from the ideal. So that means that the within means a distance from the ideal, so that means must be smaller than 0.4 ounces. So if I want to be within this distance, my distance has to be smaller than 0.4. Because remember, this distance here would be 0.1, and this distance here would be 0.2, and this distance here would be 0.3. So these numbers are within 0.4, and they're all smaller than, yeah? So that means that my tolerance, because remember, this distance from center is my tolerance or my absolute value. So that means then that my tolerance has to be less than 0.4 ounces. Okay? So that's important. This sign right here. I'm going to put a number of dots there so we don't confuse that with an equal sign. Although in this case it could also be equal to. So we could put the less than or equal to sign. Okay. So that means when we write our equation, as I had in the PowerPoint, we had the absolute value of x minus, that's my ideal, has to be less than or equal to my distance from center. So how would we figure this out if I'm just given the equation? Well, since I have my absolute value by itself, it's very important that this absolute value doesn't have anything happening on the outside of it. So that's all by itself. That means then I can put it into two cases. So I'm going to have case 1, and I'm going to have case 2. So case 1, we can think of that as is. So what's inside my absolute value, I'm just going to take it out and leave it exactly as is. I'm going to write it as x minus 12 is less than or equal to 0.4. Okay? So notice there's no more absolute value. But I have to have a case 2. Because remember, we look up here, we're going to have 2 different answers on either side, right? Of either side of our ideal. That's our ideal. So case 2 is going to be the negative or the opposite of what's inside. So I'm going to write the word opposite. The opposite of inside. How is that? Well, let's look. Here, this is opposite to this, correct? Yet, when I figure it out, I get a positive value on either side. So the opposite. So the opposite, I have to take the opposite of everything in yellow is less than or equal to 0.4. Okay? People teach this a little differently. You might see it done a little bit differently in some other examples. Let me see if I can zoom in here so we can see exactly what's going on. Okay, so now I have it set up. This was how it was inside the absolute value. Now I'm taking the opposite of what's inside the absolute value. So now I'm going to do these one at a time. So this one here, I'm going to want to get x by itself, which means I have to get rid of this 12. So I have to add 12 to both sides. So that means this turns into a 0. So I'm left with x is less than or equal to 12.4. And that was one of our values that we had on our number line, wasn't it? That was our upper limit right there. Upper tolerance. Okay? So that's one answer. So now I have to do the opposite case. There's 2 ways I can do this. A lot of you like to do distribution. So remember that negative is the same as -1. So you can think of that as a -1 being multiplied inside. So that leaves us with negative x plus 12 is less than or equal to 0.4. Okay, so let's go ahead, let's get rid of this 12. That means I have to subtract 12. So then that means I have negative x, because this turns into a 0. That negative is still in front of the x, is less than or equal to, well, if I have negative 12 plus 0.4, I'm going to have negative 11.6. But I don't want negative x. I want positive x. So you could either multiply -1 to both sides, or you can divide -1 to both sides. I'm going to go ahead and divide, since that's what most of you are comfortable with. So remember, when I divide by negative, my inequality flips. So this gives me x is greater than or equal to 11.6. So that was my other value. So if we look back up here, what we first talked about, there it is right there. Okay, so now we want to talk about graphing. So let's say we didn't have the pictures that we've done before, and we're just asked to graph our answers. And this looks like we have 2 answers here, but I have to figure out how to graph this. So if I'm not sure, I'm going to try to figure it out. I always use what I know to figure out what I don't. So I'm going to do my number line, and I'm just going to put 12.4 there, and then I'm going to put 11.6 there. I just arbitrarily marked it down. I don't know if that's an accurate distance there. So x is less than or equal to 12.4. So I think, where is x smaller than 12.4? Well, x is smaller than 12.4 here, and here, and here, and here, and here, everywhere this way. So that's where x, everywhere that way, is less than. Okay? Now, this one here says x is greater than or equal to 11.6. Well, if I'm thinking about greater than, I'm thinking about in the other direction, aren't I? I'm thinking about, well, this is 11.7 is bigger, and so forth, yeah? So that means this one starts here, and goes all the way there. Well, where do the lines overcross? Where are they both within? So within is everything that they share. Okay, so it's everything in between. So that means when I graph it, it can be this, it can be this, and it's everything in between. I am not going to, this is not a part of the solution, and this is not a part of the solution. Okay, my x is right between those two. So remember, my bottles, I could have 12 ounces, which was perfect. I could have 11.8. I could have 12.2. I can have any of those different values of weight or volume for my bottles. As we see, that was what we had up here. So the last thing I want to point out to you is there's another way that we can look at this to try to figure out how we would graph it. So if I were to read this, I would read it like this. I would say something like the absolute value. Notice I'm not going to read what's inside. Too many words is confusing. So I would say the absolute value is less than, but I spell it funny, okay? And I'm just going to stop there. I don't care that it's also equal to. So when I say that the absolute value is less than, this is an and. And when we have an and problem, I'm going to say 99% of the time, because there's some exceptions, that you're going to graph it so that the points come together.